So right now I want to talk about this issue. This issue means furthest the building you can reach, and it's like this graph. The rules is when you encounter the decreasing order, that's do nothing, and when you encounter increasing order, and you have two choice. One choice is use brick and to reach the higher building, and another choice is use ladder to the higher building, and the ladder is a for the ladder it costs the minimum, and for the building and for using bricks, and the cost is the difference between the first lower building and the second higher building. That is hi minus 1 plus 1 minus hi. So how to consider this problem? And the problem I want to use a graph to explain it. To draw, and I need two expressions, so many building like this. This is building. For the naive solution, I think it's use a DFS. For DFS, when I go, DFS is input the building array and the height, and I will to go the traverse the building operation. When the building operation, when I go this building operation, it's more than the previous building operation, and it has a difference of height. So in that solution, I have two choice. One choice use the bricks. Another choice is use the ladder. And for every DFS step, for the first choice, and I need to use the cost. And for second choice ladder, and I will not add the cost. For DFS, I have a 3 parameter. One is the building array, and another is the building current operation, and the second last is the cost. It has two choice, one choice, and two choice. One choice and the building and the operation also plus one, and the cost plus the depth of the building height. Another is building operation plus one cost, and I need more additional information is for the brick. Use how many brick, use how many ladder for the ladder. So that means the DFS will be finish traverse all the possible paths, and to get the maximum value path. The corner case is when I use all the bricks and the ladder, and I will return the final result. For the DFS, the time complexity is if I have for every operation, and it has two choice. So the two choice, and if I have about assume n increasing order, and it's all to n power n, it is exponential level time complexity. It cannot accept. So for the one, I will to study. So the next solution is to greedy Grade is for every building, and I will consider it. It means when during I visit the building process, and if the building for the previous building, and if let's assume I have a 6 ladder, and in this previous building, and I have I have the 7 increasing sequence, and during this range, and I need to I have to use a break to reach another building, and the rest of 6 increasing building can use a ladder. So in this situation, and I use a greedy thinking, and to let the smallest difference of height use a break, and all the rest of six increasing sequence use a ladder. And so if I select this building, use a break to reach the next building, and I will verify the later building position cannot impact this selection, because if I have another 2 increase situation, and for this 2, if this 2 add into the previous situation, and it's not impact this selection, because if I add this 2 into the previous selection, and it's at least the previous 6 increasing order is more than this operation. So no matter how many later matched scenario add into the previous, it cannot impact this selection. So I can use greedy thinking, and for I use a pq data structure implement this process, and when I add the increasing order to the pq, and more than the lambda numbers, and I can use the greedy to handle it, and until we have no breaks to reach the building. So I will use a pq to heap to implement it. I will define the get the heap size. Yes, and the priority queue to save the current visit building information. The difference between the height, the difference height between the 2 building. New priority queue. I will use this one, and the break. When I use one break will be handle it. Will be return the furthest building ID. Okay. I will check which building I can reach in time x1 and I minus n and plus less than, and the PQ will be add the building. If this is a increasing order, GS current index and more than the previous index. So I will add the PQ into PQ push pull pop offer. The PQ offer the difference. The difference is a height difference. I plus PQ whatever, yeah. Difference. So if the PQ number more than the letter PQ size, more than letters, and if PQ peak number more than brick, that means this bricks cannot reach the higher building, and return I. This is reach. This is furthest building index. And if cannot, else if the PQ more than bricks, and then brick will be bricks minus PQ pop. Pop the current optimal selection bricks plot, and which one will be for finished, and I can reach the last building. Everyone I will PQ the offer. Continually PQ will add the current difference, and the top is the current optimize selection. And I will try run it. PQ pop breaks method pop pull the current. Why is the file extraction the 6 building? This building cannot reach. And I have to use a ladder. Cannot reach. If the current breaks and the nodes can reach the current index, that means the previous index is our result. Yeah, okay, I will get it. I will try more test case. Okay, I will try to submit. So that's passed. So the basic thinking is for visit the increasing scenario, and every difference. First, I need to add to PQ. Use PQ to get the current minimum height difference. The height difference can use the brick to reach the next higher building. That is a currently optimal selection. this currently optimal selection cannot impact the later selection. That is greedy thinking. So I will use the simple code will implement it. And I can try change this code. And if continue, if the building is less than the next building and I don't do nothing, I will to try this one. If pq and every current building, the current building height size will be at the pq. And then if I cannot reach the next building, and I will return the index. And if the more ladder, and I will to cost some breaks for this height difference. And finally, if the loop is finished, I can reach the last building. So that is finished, and hope this greedy thinking can help you. And I think the process to consider this problem is important. Let's come together to solve the legal problem. So thank you very much.